That sound? That's not science fiction. That's a real recording from the surface of Venus, captured in 1982 by a Soviet probe called Venera-13. It survived for 127 minutes on a planet hot enough to melt lead, under pressure that would crush a submarine. And it sent back something nobody expected. But here's the part that doesn't make sense. While the entire world was obsessing over the moon landing and Mars rovers, the Soviet Union was quietly doing something insane. They landed on Venus. Not once, not twice, 10 times. 10 successful landings on the most hostile planet in the solar system. They took the first photos of another planet's surface. They recorded the first sounds from another world. They drilled into the soil and analyzed what was down there. And buried in that data are chemical signatures, atmospheric readings, things that to this day NASA still cannot explain. We're talking about particles the exact size of bacteria floating in the clouds, an unidentified substance absorbing ultraviolet light that scientists have been trying to name for 100 years, and a gas called phosphine, a molecule that on Earth is almost exclusively made by living organisms, showing up at concentrations thousands of times higher than anyone thought possible. And here's what should have made front-page news. Some of this evidence was sitting in NASA's own archives since 1978. Nobody thought to look. So how did we miss this? How did the most promising lead for alien life end up buried in 40-year-old Soviet data tapes? And why, after 3 decades of ignoring Venus entirely, are 5 different space agencies now racing to get back there? It starts with understanding what Venus actually is, because this planet is nothing like what you think. Most people hear Venus and think hot, dead, boring. End of story. But Venus is actually Earth's twin, almost the same size, almost the same mass, same rocky composition, similar gravity. If you stood on Venus 4 billion years ago, you might have been looking at blue skies and liquid water stretching to the horizon. Climate models now suggest Venus had stable oceans for up to 2 billion years. Life on Earth needed roughly 500 million years to get going after the oceans formed. Venus had 4 times that runway. It didn't just have a shot at developing life. It had a better shot than Mars ever did. So what happened? Carbon dioxide happened. Venus's atmosphere started trapping heat. The oceans began to evaporate. Water vapor trapped even more heat. And a feedback loop kicked in that nobody could stop, like a thermostat cranking itself higher and higher with no off switch. It ran for millions of years. The oceans boiled away. The surface climbed to 465 degrees Celsius. Your kitchen oven maxes out around 260. Venus is nearly double that, hot enough to melt lead, zinc, and tin. And then there's the pressure, 90 times Earth's atmosphere. That's what you'd feel 900 meters underwater, deeper than most military submarines can dive. The surface of Venus is one of the most violent environments in the known solar system, and NASA hasn't sent a dedicated mission there since 1994. Over 30 years. That's longer than the entire Soviet Venera program lasted. Mars got the rovers, the helicopters, the billion-dollar sample return plans. Venus got nothing. But before that gap, one country absolutely dominated this planet. Starting in 1961, the Soviet Union launched one of the most ambitious and most overlooked space programs in human history. They didn't just visit Venus. They tried to conquer it, and it nearly broke them. The early Venera missions were a disaster. Venera 1 lost contact on the way there. Venera 2 failed at flyby. Venera 3 crash-landed and sent back nothing. The probes kept dying, crushed by pressure, fried by heat, swallowed by an atmosphere far more extreme than anyone realized. Here's the thing. The Soviets didn't even know what they were up against. Venera 4 descended into the atmosphere in 1967. The Soviet Union proudly announced it had reached the surface. Then American data from the Mariner 5 flyby came back. It showed Venus's surface pressure was 75 to 100 atmospheres. Venera 4 was built to handle 25. It had been crushed long before it touched the ground. The Soviets had to publicly retract the claim. They hadn't just failed. They'd been engineering for the wrong planet. So they adapted, built tougher probes, massively over-engineered. Think of it like building a submarine, wrapping it in a heat shield, and dropping it into a volcano. That's roughly the problem they were solving. And in December 1970, they cracked it. Venera-7 became the first spacecraft to soft land on another planet. But even that was barely a success. The parachute failed during descent. The probe slammed into the surface at nearly 60 kilometers per hour, fast enough to crumple a car. It bounced onto its side, went silent. Everyone assumed it was dead. Then, weeks later, a radio astronomer named Oleg Rzyga was reviewing the recording tapes. He found something buried in the noise: 23 minutes of faint signal. The lander had been transmitting the whole time. It just couldn't aim its antenna because it was lying sideways in 465-degree heat. That one discovery, hidden in the noise, changed everything. After Venera-7, the floodgates opened. Venera-8 confirmed the surface data. Venera-9, in 1975, sent back the first photographs ever taken on the surface of another planet. Sharp-edged rocks, basaltic terrain, an alien landscape bathed in a dim orange glow. And then came Venera-13, March 1982. This is the one that matters most. Venera-13 was designed to survive 32 minutes on the surface. It lasted 127, nearly 4 times its own life expectancy, in conditions that would destroy almost anything humans have ever built. It captured the first color photographs of Venus's surface. It recorded the first sound from another world. It drilled into the ground, scooped up soil, and analyzed it in a sealed chamber. The rocks on Venus are basalt, the same type of rock that forms Earth's ocean floors. If you've seen the black volcanic rock on the beaches of Hawaii or Iceland, you've seen basalt. Venus's surface chemistry didn't look alien. It looked disturbingly familiar, like a dead, scorched version of home. To put that in perspective, the Soviets landed on Venus more times than any country has successfully landed on Mars. And almost nobody knows about it. But the surface isn't the strange part. The strange part is what the probes found in the atmosphere on the way down. During descent, multiple Venera missions detected particles drifting through Venus's lower atmosphere. Particles roughly 1 micron in size. A micron is a millionth of a meter, about 1/50th the width of a human hair. On Earth, that's the size of a single bacterium. The Venera probes found particles exactly that size floating in Venus's clouds. At the time, nobody connected the dots. It was filed away as atmospheric dust. Unremarkable. Turns out, it might be the most remarkable data point in the entire program. And it gets weirder. Between about 48 and 60 kilometers above that hellscape surface, there's a zone in Venus's atmosphere where something unexpected happens. The crushing pressure drops to roughly Earth sea level. The temperature cools to somewhere between 30 and 70 degrees Celsius, the range of a warm summer day. Imagine that. 50 kilometers above an inferno that melts metal, there's a layer where you could survive. You'd need an oxygen mask and protection from sulfuric acid. But your body wouldn't be crushed or cooked. It's the most Earth-like environment anywhere in the solar system outside of our own planet. More hospitable than the surface of Mars. And it's exactly where those bacteria-sized particles were floating. So what is it? What's drifting through Venus's habitable cloud zone? 100 years of looking and nobody knows. Since the 1920s, astronomers have noticed that something in Venus's upper clouds is absorbing ultraviolet light. A very distinctive absorption pattern. Dozens of proposed explanations over the decades. Sulfur compounds, iron chloride, exotic mineral dust. None of them fit all the data. Scientists have a name for this substance. They literally call it the unknown UV absorber. That's not a placeholder. That's the actual scientific term. After a century of trying, that's the best we've got. But here's what does match. The spectral absorption pattern of certain species of terrestrial bacteria. It's not proof, but it's a coincidence that's been getting harder and harder to ignore. And there's one more piece. NASA's Pioneer Venus probe detected a separate class of cloud particles that are non-spherical. If they were liquid drops, they'd be round. These aren't. Something solid is floating in those clouds. So let's take stock. bacteria-sized particles in a habitable zone, an unidentified UV absorber matching microbial spectra, solid objects drifting in the cloud deck. All of this collected across decades of Soviet and American missions, sitting in archives, waiting. Then, in September 2020, a team of astronomers pointed a telescope at Venus, and everything suddenly mattered. Jane Greaves at Cardiff University and her team used the James Clerk Maxwell Telescope in Hawaii to look for a specific gas in Venus's atmosphere, phosphine. It was almost an afterthought. Greaves herself said it seemed worth investing a few hours of telescope time. They expected to find nothing. They didn't find nothing. They found phosphine at roughly 20 parts per billion. Earth's atmosphere has a few parts per trillion. Venus showed roughly 10,000 times the concentration anyone thought possible. That's not a rounding error. Why does phosphine matter? On Earth, it's a nasty gas. You find it in swamps, in sewage, in the guts of animals. It's made by anaerobic bacteria, microbes that thrive without oxygen. Finding it on a rocky planet with an oxidizing atmosphere is like finding a campfire in the middle of the ocean. Something has to be producing it, and it shouldn't be there. The headlines exploded. Signs of life on Venus. But then came the backlash. Other teams reanalyzed the data, found a processing error, said the signal was actually sulfur dioxide, a common Venus gas. Phosphine levels were revised down. The story seemed dead. But it wasn't. The original team defended their detection. Their reanalysis still held, statistically rock-solid by the same standards used to confirm the Higgs boson. And then something else surfaced. A researcher named Rakesh Moghul went back and looked at archived data from NASA's own Pioneer Venus probe, the one that dropped into Venus's atmosphere in 1978. He found what looked like phosphine signatures, deep in the cloud layer. That data had been sitting in NASA's archives for over 40 years. On microfilm, in filing cabinets. Nobody had looked for phosphine because nobody thought to ask. And it gets stranger. In 2022 and 2023, Greaves's team went back for 3 more observation campaigns. They didn't just find phosphine again. They also found ammonia, another hydrogen compound with absolutely no business existing in Venus's oxidizing atmosphere. Dave Clements at Imperial College London, one of the lead researchers, put it bluntly. He estimates a 10 to 20% chance the explanation is biological, an 80 to 90% chance it's chemistry nobody understands yet. Both answers are extraordinary. If it's life, it's the first evidence of biology beyond Earth. But even if it's not life, even if it's just unknown chemistry, it means we don't understand the atmospheric physics of our nearest neighbor. Every model we've built for exoplanet atmospheres would need to be reconsidered. Now connect the dots. The micron-sized particles from the Venera missions. The unidentified UV absorber matching bacterial spectra. The solid cloud particles that can't be liquid drops. Unexplained trace oxygen that both Venera and Pioneer detected. And now phosphine and ammonia at concentrations no known process can produce. Each one individually has a mundane explanation. Dust, instrument noise, exotic chemistry. But together, the pattern starts to look like something. And that's what's keeping planetary scientists awake. So here's the question nobody is asking out loud. If the Venera probes detected bacteria-sized particles in the 1970s, if Pioneer Venus may have logged phosphine in 1978, if the UV absorber has been unexplained since the 1920s, is it possible we've had evidence of life on another planet for decades, and we simply weren't looking? This isn't just a funding gap. It might be the biggest missed lead in the history of science. Since the mid-1990s, NASA has launched over a dozen missions to Mars. Rovers, orbiters, landers, a helicopter, a sample return mission in the works. 0 missions to Venus. Mars got everything because Mars looks the part. Canyons, polar caps, ancient riverbeds. It looks like somewhere life could exist. But Mars may have had liquid water for a few 100 million years, early in its history. Venus may have had it for 2 billion. That's not a close race. And then there's the dark comedy of how we handled the data we did have. Soviet Venera results were published in Russian journals behind Cold War barriers. Much of it was only gradually shared with Western scientists. Some pioneer Venus data was stored on physical microfilm at NASA's Goddard Space Flight Center. When the Phosphine story broke in 2020, researchers wanted to check those tapes immediately. They couldn't get into the building. COVID lockdowns. And one detail from the Venera program feels almost symbolic. On Venera-14, one of the camera lens caps popped off after landing. It fell directly onto the exact spot where a spring-loaded arm was supposed to press against Venus's soil. Instead of measuring the surface of another planet, the instrument measured its own lens cap. The data existed, the opportunity existed, and we fumbled it anyway. Across all of human history, we've had maybe a few hours of total contact with Venus's surface. Every second of data from those missions is precious, and some of it sat unexamined for decades. Now here's the thought that changes everything. We've been looking for life on surfaces. Mars's surface, Europa's ocean floor. But what if life on Venus never lived on the surface? What if, as the oceans slowly evaporated over millions of years, microbial life did what life always does? It adapted. It migrated upward, into the clouds, into that narrow band between 48 and 60 kilometers where the temperature and pressure match Earth's surface. It wouldn't be the strangest survival strategy in biology. It would just be the first one we found off-world. For 30 years, Venus was the forgotten planet. That's about to change. And there's a geopolitical irony to it. Russia's Venera-D was supposed to carry the torch. A next-generation lander and orbiter. Originally a joint mission with NASA, planned for 2029. Then the invasion of Ukraine shattered US-Russia space cooperation. Roscosmos suspended the agreement. The mission slipped to no earlier than 2036. The country that conquered Venus is now falling behind in the race to go back. But others are stepping in. Right now, 5 missions from 4 different agencies are being built. NASA's Da Vinci will drop a probe directly into Venus's atmosphere, the first American spacecraft to enter those clouds since 1978. It's specifically designed to sample the chemical anomalies the Venera probes flagged. NASA's Veritas will orbit with high-resolution radar, hunting for active volcanism. The European Space Agency's Envision will map Venus from core to cloud tops. India's ISRO is preparing a Venus orbiter. And Rocket Lab, a private company, is building a Venus Life Finder specifically designed to search for organic molecules in the cloud layer. And here's the biggest implication of all. Venus-like planets are among the most common type we've detected around other stars. If Venus harbors life, even just microbes in its clouds, the habitable zone is far wider than we thought. Life doesn't need a perfect surface. It doesn't need flowing rivers and gentle seasons. It might thrive in atmospheric layers, in acid clouds, in places we've been writing off as dead zones. The universe could be far more alive than we ever imagined. We spent 50 years scanning the cosmos for alien signals. We sent rovers to Mars. We planned missions to icy moons around Jupiter and Saturn. And the whole time, the answer might have been one planet over, recorded on Soviet data tapes, stored on NASA microfilm, hiding in plain sight. The Venera probes are all dead now, crushed, melted, swallowed by a planet that doesn't tolerate visitors. But the data they sent back is still alive. And 40 years later, it's still waiting for us to understand what it was trying to say. If this is the first you've heard of the Venus story, share it with someone. Because what happens next could change everything we think we know about life in the universe. And if you want to be here when it does, subscribe. The Venus chapter is just getting started.